important terms used in lenses. The first is principal axis. What is the principal axis? This is a lens. It has two curvatures. Okay, so this is one, this is two. So this is surface number one, this is surface number two. Each spherical surface has a center of curvature because it is part of a sphere. And the center of the sphere is the center of curvature of this surface, 1, P1. And the other one also has a center of curvature. So this is the center of curvature of surface 2 and this is the center of curvature of surface 1. So just join these two and extend. This is the principal axis. So what is the principal axis? It is the line joining the center of curvature of two spherical surfaces forming a lens. Okay, so line joining the center of curvature of the spherical surfaces of the lens. Here I done two spherical surfaces of the lens. Okay, now optical center. Optical center is a point in or outside the lens through which it is a point in or outside the lens. Okay. Through which rays of light pass undeviated. Undeviated means they do not bend. It's called an optical center. Okay, of the lens. This is represented by letter O. Here, suppose this is a lens and this is the principal axis. And if this point is the optical center, then the ray of light which is passing through this point will pass undeviated. There will be no bending or reflection of light. And if you have this concave lens, this is the principal axis, this is suppose the optical center. The ray of light passing through the optical center does not deviate from its original path. And we consider thin lenses and for thin lenses, optical center always lies at the center of the lens. So it is lying in the at the center of the principal axis, which is inside the body of the lens. तो उसके सेंटर पे जो है ये लाई करता है। प्रिंसिपल फोकस, principal focus is a point on the principal axis. So it is a point on the principal axis of the lens. Where all the rays of light parallel to the principal axis meet or appear to meet after passing through the lens. So it is a point on the principal axis of the lens where all rays of light parallel to the principal axis meet or appear to meet after passing through the lens. Let us understand this with the help of the ray diagram. Take the convex lens, the principal axis, the optical center, and there are rays of light which are coming from the object, but these are parallel to the principal axis. So we know that the rays of light, after they encounter or pass through any reflecting medium, will always bend. So how these parallel rays will bend? They will bend and such that all the rays will pass through, which lies on the principal axis. And this point is called the principal focus of this lens. That is the meaning of the statement. So in this case, the rays are actually at one point. Okay. And let us see what happens in case of a concave lens. I have this concave lens, the principal axis, position of the center, and the rays of light are incident parallel to the principal axis. So these are all the rays of light which are parallel to the principal axis. Now we know the rays of light parallel to the principal axis, rays of light diverge when they pass through a concave lens. So they will diverge. So this is the direction in which these rays will bend. Okay, so these rays actually do not meet at any point because they are spreading out and diverging. So when you extend backwards, you see that these rays are appear to meet at one point. as if these rays are either originating from this point focal length represented by small f. It is the focal length is the distance between the principal focus and optical center. And optical center is O and principal focus we represent with the help of letter capital S. Okay. So OF is the distance
is equal to the focal length of the lens. So OF is the distance which is equal to the focal length of the lens. So this much distance we're talking about, F and O, distance between O and F. So O and F. So this is small f. Okay, similarly in this case, this is F, this is O. So this is the focal length. So focal length is represented by small f, and principal focus, that is a point on the principal axis, is represented by capital F. Now the principal focus that we have discussed in this case is called the second principal focus. So this is the second principal focus. So this is a point on the principal axis where the rays of light incident parallel to the principal axis actually meet or appear to meet. Now there is another one that is called the first principal focus. So we represent this by F1 and this is represented by F2. So we can simply say F or F2, but this is F1. So what is the definition of first principal focus? The position of a point on the principal axis of a lens on the principal axis of a lens so that the rays of light starting from this point the rays of light are starting from this point after passing through the lens travel parallel or appear to travel parallel. Either they travel parallel actually or appear to travel parallel to the principal axis. is called the first principal focus. Now let us understand this with the help of a diagram. So this is a convex lens, principal axis, optical center, and there is a point on the principal axis which we call the first principal focus. Now what happens? Now the rays are incident from this point on the lens. So ray will be incident something like this. Another ray, let us consider another ray like this. So the rays are originating from this point F1 such that after refraction or after passing through the lens, they travel parallel or appear to travel parallel. So in case of convex lens, the rays travel parallel to the principal axis after passing through the lens like this. So this is the case. So rays are actually traveling parallel to the principal axis after passing through the lens in case of a convex lens. Now let us understand what happens in case of a concave lens. This is the optical center, and now in this case the rays are, because this is a diverging lens and the rays actually diverge, so there's a point, these rays are coming from a point, so it will appear like this. So, and after passing from the lens, they travel parallel to the principal axis, and the rays in this case appear to be coming from a point, and that point becomes the first principal focus. So it appears that if the rays are coming from this point, and after passing, these rays travel parallel to the principal axis, and this point is called the first principal focus. So we'll see the difference. The second principal focus in case of convex lens is on the other side, the right side, where the rays actually meet after passing from the mirror, passing from the lens. And in this case, the rays appear to be meeting at this point in case of a concave lens. So here in this case, it is on the left side, and this is in this case on the right side. And here in this case, F1 is on the left side and F1 on the right side in case of a concave lens. So that is the difference. But remember one thing, whenever we say principal axis, we actually mean this second principal axis, and we will be dealing with second principal axis, second principal focus only. Okay, so principal focus means second principal focus. We shall not be dealing with this first principal focus. Okay, so whenever we talk about focal length or principal focus, we are talking about this case.